Hey everybody, and welcome to this video on multiplying polynomials. So without further ado, let's make it happen. Alright, now before we go ahead and multiply polynomials by polynomials, I want to look at a couple real number multiplication problems to show that the strategy for doing this multiplication is exactly the same strategy for doing polynomial multiplication. So for instance, if I ask you to multiply 14 by 16, you might have an algorithm by which to do it, or maybe you can do this mentally using some tricks. And one way I really like to think about 14 times 16 is with a rectangle, who has one side of length 14 and one side of length 16. In this case, the area of this rectangle should be 14 times 16. However, that's a pretty difficult multiplication to do. So what I want to do is break up 14 and 16 into 10 plus 4 and 10 plus 6. And note, this is the exact same multiplication problem as we had originally, we're just writing it a little bit differently. So now if we look at our rectangle, we actually have 4 smaller rectangles. And if we sum up their areas, we should get the total area, or 14 times 16. So let's go ahead and do it. First we get this 10 by 10 square, who's got an area of 100. Then we get this 10 by 6 rectangle, whose area is 60. Then we get a 4 by 10 rectangle, whose area is 40. And lastly, we get a 4 by 6 rectangle whose area is 24. And so we end up with an area that's the sum of 100, 40, 60, and 24 for a grand total of 224. Now note, one way to make a connection between the rectangle and the math that's written on the left is note that what we did really is we took this 10 and we first multiplied it by 10 and then we multiplied it by 6. It's as if we distributed that 10 to both the numbers in the second set of parentheses. And then we took this 4 and we multiplied it by both the 10 and the 6. It's like we distributed that 4 to both numbers in the second set of parentheses. And what did we end up with? Well, we ended up with 100 plus 60 plus 40 plus 24. And what do those sum to? 224. Our product when we multiply 14 by 16. Let's try another one. 134 times 26. Now, if I ask you to multiply those two, maybe you've got an algorithm by which to multiply a 3-digit number and a 2-digit number. Maybe you have a tricky way of doing it in your head. What I like to think about is a rectangle who has one side of length 134 and one side whose length is 26. So the area of this rectangle should be 134 times 26. But again, that's a really tough multiplication problem to do. So what I like to do is break up 134 into 100 plus 30 plus 4 and break up 26 into 20 plus 6. Again, we have the exact same multiplication problem on our hands, it's just written a little bit differently. So looking at the rectangle again, it appears that we have 6 smaller rectangles, and if we were to sum up their areas, we would get the total area, or 134 times 26. So let's go ahead and do that. First, we have a 100 by 20 rectangle, whose area is 2,000. Then we have a 100 by 6 rectangle, whose area is 600. Then we have a 30 by 20 rectangle, whose area is coincidentally also 600. And then we have a 30 by 6 rectangle whose area is 180. And then we have a 4 by 20 rectangle whose area is 80, and a 4 by 6 rectangle whose area is 24. And if we sum up each of those individual areas, we find the total area to be 3,484. Now once again, if we look at the rectangle, we multiplied 100 by 20, and we multiplied 100 by 6. Looking at the math, it's as if we distributed that 100 to both of the numbers in the second set of parentheses. Back to the rectangle, it also appears as though we took the 30 and multiplied it by the 20 and the 6. Looking at the math, it's as though we distributed that 30 to the 20 and the 6. Once again, back to the rectangle, we also took that 4 and we multiplied that by the 20 and by the 6. And if we look back at the math, it's as though we distributed the 4 to both numbers in that second set of parentheses. And in general, in both cases, what we've done is we've taken each number from the first set of parentheses and distributed it to each number in the second set of parentheses, and then summed up all the results. And in this case, what did we end up with? Well, we ended up with 2,000 plus 600 plus another 600 plus 180 plus 80 plus 24, and when we sum those together, not surprisingly, we end up with 3,484. The product when we multiply 134 and 26. All right, now let's go ahead and multiply some polynomials. And this is going to be a direct extension of what we just talked about. For instance, in our first example, all we've got is one number plus another number, times one number plus another number. It's no different than, for instance, 10 plus 4 times 10 plus 6. We're going to handle it in exactly the same way. Once again, the way I like to think about this is with a rectangle who has one side of length 2a plus 1 and one side of length a squared plus 3. Now, the full rectangle is made up of these 4 individual rectangles. So if we can find their areas, we can find the areas of the whole. Well, those 4 areas shouldn't be so bad. This upper left rectangle is going to have an area of 2a to the third power. The lower left-hand rectangle is going to have an area of 6a. The upper right rectangle is going to have an area of a squared. And the lower right rectangle is going to have an area of 3. And so we find that the total area for this big rectangle is 2a to the third plus a squared plus 6a plus 3. What did we do there? We multiplied this 2a by both a squared and by 3. Then we took this 1 and we multiplied it by a squared and by 3. Looking at the math, we distributed that 2a to both a squared and 3, and that 1 to a squared and 3, and of course, this is the product we got. Once again, in general, we want to make sure that our final product is in standard form. This one isn't quite there yet. In this second example, it's going to be the exact same strategy. I like to visualize this as a rectangle who has sides of length 3m plus 4 and 2m plus 3. And so the area of this rectangle will be the product of 3m plus 4 and 2m plus 3. And of course, this larger rectangle is made up of 4 smaller rectangles. So if we can find their areas, we can find the area of the total. The upper left rectangle has an area of 6m squared. The upper right rectangle has an area of 9m. The lower left rectangle has an area of 8m, and the lower right rectangle has an area of 12. And so, the product of 3m plus 4 and 2m plus 3 should be 6m squared plus 9m plus 8m plus 12. What did we do? I think we took this 3m and we multiplied it by both the 2 and the 3. We distributed it to both numbers in the second set of parentheses. I also think we took this 4 and we multiplied it by the 2m and the 3. We distributed it to both numbers in the second set of parentheses. And of course, this is the product we ended up with. And in general, we want to make sure that we collect all our like terms and that we're in standard form when we're all done. So the only thing I think we have left to do is to collect these 2 like terms. And our final product will be 6m squared plus 17m plus 12.